I'm sure everyone is aware by now that the seminar is being recorded and on YouTube if you're interested. And finally, if you're a Twitter user and wish to tweet about this seminar or future LEEPout events, please use the hashtag #LEEPout. So without further ado, I would now like to warmly welcome Professor Lusk and leave him the floor for his presentation. Thanks, Jayson.
Thank you very much. It's a pleasure to be here. I wish I was there in person, but this is a good substitute. And this talk is a basket-based choice experiment. I want to acknowledge my co-author, Vincencina Caputo. She's at Michigan State University, and this is very, very much a joint project. So she and I have both been engaged in this project from the beginning. So she unfortunately is not here with us because she might be able to answer some questions better even than I can. So I want to talk just a little bit about choice experiments as a method overall and kind of how they're used. So as many of you on this seminar no doubtedly know, choice experiments are a widely used method, but both to value public goods and environmental economics, but also private goods in food contexts. And I think we've seen a real explosion of this particular method in both environmental and food choice valuation. Just to give you a little bit of sense of that, yesterday, I went on the Web of Science and just searched the term discrete choice experiment and counted the number of papers by year that have been published on discrete choice experiments. And you can see this, back when I got my PhD, which is doesn't seem that long ago, but it indeed is was back in this era here. There were a trickle of papers every year using these methods, whereas today, more than 450 papers are published each year using this particular method. One question you might have is, aren't more papers overall being published? And that definitely is true. So I just thought I would compare the use of discrete choice experiments to other methods over this roughly 20-year time period. So I just picked a couple of other kind of methods related to valuation of consumer preferences. So contingent valuation, discrete choice experiment, hedonic price analysis, demand systems, travel cost. So you can see in 2000, at least in this particular database, there were about 100 papers that came up on these topics, but you can see contingent valuation was the largest share of those papers. Whereas last year, you can see many more papers being published, or at least maybe this database just includes more sources than it once did. But I think in terms of just shares of papers, you can see the real rise of choice experiments today among this subset of topics. Just under 50%, 40 to 50% of those papers are using choice experiments. If you're curious about the fields that use those choice experiments, obviously economics, but it's pretty broad. Actually, a lot of use in health and environmental studies, ecology, other social sciences. So I think it's been a method that seems to have been really popular. And I just pulled out, at least in this database and under that search term, discrete choice experiment, these were some of the top cited papers. Now, it's obviously missing a bunch of papers that use choice experiments because I know papers that are more cited. I've actually written, authored some papers that are more cited than some of these. So, those are quibbles with the database, but I think it's still useful overall just to see, the wide application of these methods. And you can see health economics, ecological economics, food quality and preference. This is a sensory science journal, public health, transportation, and of course, much more. So why do we see this particular method growing in application? There are a variety of reasons. These are the ones that come to mind for me. One is, I think there's a thought that compared to some other methods, that choice experiments do a pretty decent job mimicking the way people make decisions in the real world, particularly in the context that I'm most interested in, which is food buying. You go to the grocery store, you make a choice out of a subset of items. And so in that sense, I think there's a sense that it's there's some sort of face validity in the way the questions are asked. Also, I think compared to other methods that rely on, say, scanner data or aggregate time series data that come from government agencies, there isn't nearly the concern about endogeneity of say, prices, because we're controlling prices through an experimental design. They're varying across choice sets in a way that we control as the researcher. Another, even in discrete choice modeling, think of like the Nevo kind of papers that use the scanner data, for example. They still use the kinds of models that get used in discrete choice experiments, but because they're relying on scanner data, there's concerns about whether prices are correlated with unobserved characteristics of the products. And again, in choice experiments, we're controlling those characteristics, so we don't have those same endogeneity concerns. And then lastly, I'd say there's a really robust literature that it's sort of aimed to test the external validity of choice experiments. Are what we're observing from hypothetical choice experiments consistent with what we see in terms of, say, market shares in the real world, or what people do in real money is on the line. And I know there's a little bit of debate about this. Hypothetical bias is a problem. We tend to see people saying they're willing to pay more for something in a hypothetical survey than a non-hypothetical. But what the evidence seems to suggest, and I know it's not unanimous, but if we're interested in sort of marginal changes, so willingness to pay for one attribute versus another, conditional on making a purchase, that even hypothetical choice experiments do a pretty good job getting close to what we see in hypothetical experiments. But more importantly, I think there's been a number of studies, including some that I've done, that compare, say, market shares from a hypothetical survey choice experiment to what we see in a retail setting, and you get pretty darn close. So I think in that sense, there's a variety of reasons that have supported this rise. So how do these choice experiments look? And of course, I'm setting all this up to introduce a new method, but I think it's important to have this context for where we're coming from. Typical choice experiment, I'd say, looks something like this. And this is a study I actually did last year. And people are asked to choose a single product out of a set of competing products, and where those products are defined by multiple attributes. So in this case, the product is a chicken breast. You've got two products plus a none of these option. And these are the different attributes that are varying. So there's a non-GMO label, there's an organic label over here. You got different prices. And of course, different choices, we vary the presence or absence of these labels and the prices so that we can sort out how choice and willingness to pay is varied by these labels and prices. By the way, the purpose of this particular study that you're seeing was to study this slow growth chicken label. I'd say more recently, what I'm starting to see are more choice experiments that look like this. You can call these branded or labeled choice experiments. So you've got a particular product, and the only real attribute that's varying across choices are prices. So for about 5 years, I did a monthly survey of over 1,000 US food consumers. I called it the Food Demand Survey. And I used a choice experiment. It looked like this. Everybody got this, set of questions. Each person, I think, answered 9 choices. The only thing that was varying across those choices were the prices of the options. Here's a more recent example of a reincarnation of this food demand survey that I've been doing with Glenn Tonser at Kansas State. We call this the Meat Demand Monitor. So we've been doing this every month for about the last year. And it's a slightly different mix of products. You can see we have a plant-based patty. We added some seafood in there. But these are kind of popular, I think, because particularly if some of the work I do, I'm working with commodity organizations like the beef producers or the pork producers, and they're really interested in demand for what's happening for demand for their product, and not just that. The use of these, I think, is useful in the sense that if we're looking at specific policies that may maybe change the price of one product, not the other, I think these are kind of useful ways to go about this. Just to give you a little bit of sense of also, I think why these have been useful is in these kind of surveys that I've been involved in, the tracking surveys. So, for example, these are results from that last choice experiment kind of question I gave you. So over time, so this goes back to February, here was our March COVID disruptions in this time period here. This is just the share of people across all the choices we ask that were choosing ground beef. You can see there's a little bit of wiggle room, but it's pretty stable. And then here's that plant-based patty. I know there's been a lot of interest in the emergence of these alternative plant-based proteins. And you can see it's very small, 3%, which maybe doesn't coincide with the real rise in sales that we've seen in these products, but I think these data seem to suggest that the rise in sales is probably being explained by a rise in availability to consumers. So, as we've been doing more choice experiments that look like this, I think as I've been talking with Vincenzina and others, the traditional choice experiment approach starts to look like it has some real disadvantages. And in particular, that kind of traditional attribute-based product, that actually makes sense if we're going to ask people to choose a single product. If you're going to buy chicken breasts, you're probably only going to buy one package, and you're going to buy one package instead of the other. And so those kind of traditional attribute-based single decisions make sense if we're interested in willingness to pay for, say, something like organic or a non-GMO label. But if what we're really interested in is, how much do you value a beef steak versus, let's say, a vegetable dish? It starts to make less sense to just do it as a binary choice, because when we think again about this real world shopping, environment, you can buy both. You don't have to buy either one or the other. And I think, as we all know here intuitively, these different food items can act as substitutes or complements. And that traditional choice experiment approach forces all products to be demand substitutes. And intuitively, you can see that, because if I choose one product, I don't choose the others. And as a result, if you, for example, calculate elasticities, all those cross-price elasticities are going to be positive. They have to be demand substitutes. It's just a function of the model in the way it's constructed. Whereas I think in reality, we know different products can also be complements. And so we started thinking about what approaches can we use to allow more flexible types of substitution patterns. Well, I've already talked about other kinds of consumer analysis. We have traditional demand systems. So this might be something like the AIDS model, or various other demand type systems. The challenge with those is typically you got to aggregate over people. So you're aggregating high income with low income, men with women, different races. Also, you tend to aggregate across products because you have a problem with dimensionality, that you get too many parameters if you have too many different kinds of products. So rather than a particular product like a beef steak, let's say, and pork bacon and ground beef, you aggregate everything up into something like beef and pork is what's typically done. But a lot of the interest here, I think, is in the actual specific cuts and specific types of products. And if you have scanner data, the other thing is you got to deal with is what period of time am I going to aggregate over? So you got lots of issues with aggregation. And I've already talked about this, so I'm not going to dwell on it, other than, there are all the historical concerns with endogeneity. And so, if you read the literature, particularly in food and agricultural economics, you see many fewer papers published on demand systems today than, say, 20 years ago. And I think a lot of it is really due to this endogeneity. It's hard to assert causality with these kinds of models, and choice experiments allow us to escape that problem a bit. So the purpose of this paper is to try to work around some of those problems we mentioned before. So we've got a method that we're introducing here that we're calling a basket-based choice experiment. The real purpose here, as I've mentioned, is to allow for more flexible substitution patterns. This is not necessarily innovation, but I think we're going to use an estimation approach here that's not very commonly used. And even though it relies on some literature from the 1970s, I think it's really only in the last few years that you see papers that have started to use this. So I'll talk about the details here in a minute, but just to give you a heads up, we're going to use an approach that uses a composite conditional likelihood function to estimate something called a multivariate logit. And what we're going to do is essentially model the probability of choosing bundles rather than products. So again, just to reiterate, the basic idea here is that this basket-based choice experiment, the way it differs is people can choose multiple combinations of items to form a basket or a meal, just like when you're shopping. You can choose both the chicken and the beef. You can choose the chicken and a vegetable. So it allows you to put more things in your basket. I do want to say too, there is a lot of work that does similar things to this. So I don't want to claim, that we have absolute novelty here. There have been approaches that ask consumers things like that use a fairly traditional choice experiment approach, but ask people how many of each item would you buy? And there's been some papers that have used something like this basket-based choice experiment, but not quite in the way we're doing it, not in a way that you really can sort out and tease out all the parameter estimates that we want to. So I don't want to claim absolute novelty here, but I'd say it's at least newish is maybe the way I would say it. So what is this basket-based choice experiment? The best way to illustrate it is just to give you an example. So we chose a potential basket that has 21 different food products in it. And this is actually a screenshot of what the participants in our study saw. So these are the actual products. The mix of products we chose based on data that we have from US consumers about the relative frequency of purchase of different kinds of items. So we tried to pick a subset of items that were most popular with consumers and then choose a mix of both fresh and processed items, both in fruits and vegetables and in some meat categories, plus a few ready to eat items. So for example, here are fresh tomatoes, but we also down here have tomato soup. So you have the fresh tomatoes and a processed version of the tomato. We have, fresh meat, like say ground beef, but we also have hot dogs, so a processed version of the same. And then, again, canned fruits versus a fresh fruit. So we try to have some mix of those things. So this is the screen everybody saw. The only difference really across different choices people made were the prices that varied. So this gives you also an example of a person that say they chose, they clicked add to the cart, they clicked the ground beef, they clicked the tomato soup, and they clicked tomatoes. And when they did that, on their screen down on the right hand side, it would give the participant a running total of how, the cost of their basket. I guess they also in this example chose lettuce as well. So we thought this was important so that people could see the cost consequences of their basket overall. And just so you know too, there's nothing, it took a lot of work to do this. Vince and Sina did most of the hard work to make it look this nicely. But in terms of programming, we're using something called Qualtrics, which is a very popular and common survey tool and technique. So we're not using something super specialized or something that required fancy, programming. This is a very common survey tool, Qualtrics, that we use to create this platform. The other thing we did is once somebody said check out, we gave them this summary of their choices just to confirm with people. So they can see everything in their cart and they can see the total. And it also gives people, you can see the little X's over here that if they decided, oh, I really don't want the ground beef, I can click this and it will remove it from the cart and update this. So as I said, the basic basket looked the same for everybody except we randomized the order of items and the prices varied. So prices of items varied across the baskets. We wanted to vary those obviously because we're trying to estimate how much people are willing to pay for each item, and then also these substitution or complementary patterns between products. In our particular experimental design, we let each item vary at 3 different price levels. So just in terms of possible baskets we could have created, there are 3 to the 21 possible baskets. We decided to use a fractional factorial design so that all the prices are essentially uncorrelated with each other across all the baskets. So that required us using 72 baskets. That was, we felt, way too many to ask any individual person to do. So we blocked those into sets of 9 questions each, and each person was randomly allocated to one of those blocks. So a question that came in over here is each individual buying just for themselves for one meal? What is the no buy option? So let me see. I don't want to be mistaken here. So I'm going to do something real quick. This is probably a little dangerous, but I'm going to actually open the survey I have and read what we actually told people. So I'm not lying to you. There's one advantage of doing this virtually, right? I can have multiple screens open while I'm talking to you. So this is what we told people. We said, imagine you're at the grocery store. You're buying ingredients to prepare a meal for you or your household. We told them there's 9 questions that are going to follow. You can, indicate which item or combination of items, so forth. There's, a little more detailed instruction there, but here's the key answer to your question. We told them, remember to select the food item or combination of items for only one meal for you or your household. And then we told them you also have the option to select no buy if you would not buy any of the food products or items offered in the question. So hopefully that gives you an idea of the task that we asked people to complete. Presumably you could do that in a number of different ways. You could say, you're on your regular shopping trip. Buy everything you're going to do for your whole week's worth of shopping, and that you might have gotten a little different kinds of answers. There's also a question that came in the chat that asks, do we lose some power with this blocking? Yeah, possibly. Now, we don't ever try to estimate a model where it's just a model per person. We don't have enough. I don't think there's enough degrees of freedom. Well, there isn't enough degrees of freedom to do that. So this is also just really an issue of sample size. And we have over 1,000 respondents. So if you take 1,000 divided by 8, that tells you how many people in each block. So it's more than 100. But we're not trying to estimate block effects per se. The block is kind of a nuisance factor. Maybe another way to think about it is across all those, if you want to take that 1,000 respondents and divide it by 72, that kind of tells you how much, divided by, I guess each person answered 9 questions. So I'm just trying to see how many times each particular question was represented in the sample. And I guess it would be 8 divided by 1,000 roughly divided by 8. So I don't know. I'm pretty comfortable with that. As you'll see, the proof is in the pudding. Pretty much all of our estimates are highly significant. So I feel pretty confident with that.
Given that you're stopping for questions, Jayson, I was wondering if you could maybe explain a bit more, very briefly, because I don't want to take much time, how you basically allocated the price levels to people and how you explain the variation. Because, did you try to allocate specific prices to specific people depending on, for example, their current level of expenditure on these products?
Yeah.
Or was it randomized, and how did you explain the variation across choice cards, if you can?
Yeah, good question. It's totally random. So you randomly get assigned to one of these blocks, and then those blocks have prices that are just predetermined by this fractional factorial design. And so, I think the advantage of that is we know all these things are orthogonal with each other, meaning, which is, I think, typically in a linear model, which our model is not going to be linear, is associated with, minimizing the size of our standard errors, but it also gets back to that endogeneity problem. Like, we're not concerned that, some unobserved variable that we're not picking up is correlated with prices. We hope not, at least, because we've randomly allocated essentially people to prices. In terms of the price levels, as I mentioned, we had basically a high, medium, and low. We tried to use publicly available data on roughly average prices at about the time we did the survey to pick our middle. And then I think we used sort of a percentage increase, for the lower, and that same percentage increase for the higher for each product. I can't remember exactly how we chose the spread there, but in general, in these kind of choice experiments, I think you want a spread big enough that you can, any sort of willingness to pay you estimate is within the range of prices that you used. But in the paper we have, if you look at the appendix, we show the range of prices that we that we used.
Thank you.
The
There is another, yeah, sorry.
No, I was going to say the important thing here is if you run the correlation of prices of the 21 products we have across all the choices, the correlation between, say, the price of ground beef and the price of lettuce is that cross correlation is 0 or something very, very close to 0.
Which is good. I think I've seen another question, but I don't know. Yeah, maybe we could pick this up as well. And so the question was, did the choice sets vary across blocks? Does it influence the results?
So the only thing that's different across blocks is our prices. So like the basic structure like this is the same in every question. The only thing changing are the actual price levels. Now it could be that the order changes because we randomly change the order. We don't want people always choosing tomatoes because it's first, for example. But that's just that order just gets randomly varied across people. But the blocks, all the blocks are doing are just changing these prices a bit. Well, I'll go forward a little bit, and then we can, of course, take other questions as we go. So I think what we're trying to do here is combine the advantages of a traditional demand system, something like an AIDS model. The advantage of those is it allows a rich substitution pattern with some of the advantages of these classic discrete choice models, meaning the lack of endogeneity. This gets back to this discussion about prices varying exogenously. And hopefully, we don't know this and we don't prove that in this study, but hopefully some high external validity. So how are we going to model all these choices? And if any of you saw some early versions of this paper, Vincentine and I spent a lot of time, frankly, kind of floundering around with how to model this. As it turns out, there's actually a pretty rich literature that we stumbled upon. Actually, we got some kind emails from some folks that said, "Hey, have you seen this literature? We think it might be useful for the kind of stuff you're doing." And it's basically a literature that uses something called a multivariate logit. And here's how we use it. So those of you that have done discrete choice modeling or choice experiments are familiar with the random utility model. So you've got a systematic component, you've got a random component. So this is the systematic component, but the thing I want to point out here that's a little different already is, so this is a systematic utility individual I has, but it's not for a particular product. So B is not an index of, say, ground beef or lettuce. B is a basket. So the assumption here is that you're deriving utility for an entire basket of products. And that basket then is going to be comprised of, these are dummy variables essentially for whether a particular item is in your basket or not. So in our case, we have 21 of these items. So these X's are dummy variables. So we're summing across all 21 possible items. And if say item 1, let's say tomatoes are item 1. If tomato is in your basket, this takes a 1. And then this alpha is just like a base utility you get from, say, tomatoes. This part over here is really where the kind of substitution or complementary type effects come in, because here, this is if you have 2 items in your basket at the same time, and this gamma parameter is essentially, whether it's sub or super additive. So if I have a tomato and let's say a ground beef, and this is a positive number, it means my overall utility of the basket is rising when I have both of these products in my basket at the same time. There's a couple of papers, actually one in the American Economic Review last year, that rationalizes this as essentially a second order Taylor series approximation to any underlying utility function. It's possible to imagine adding 3-way, 4-way type effects out here. Although as I'm going to show you, the number of parameters you get here is going to blow up on us pretty quick. Imagine we've got 21 products, right? So this summation over here is a 21 by 21 essentially matrix of products. So I'll explain this part and maybe look at some of the questions that came in the chat. So this alpha, one thing that's important about it is you can then let this base utility parameter depend on other coefficients. So for example, prices are a pretty darn important one. So we're gonna let the price of say tomatoes affect the, the utility that tomatoes bring into the basket. We would expect this beta parameter to be negative. If the price of an item goes up, it's less likely to be in your basket, or if it's in your basket, the overall utility of that basket's going to be lower. And these are, any other variables you want to add. In our case, we add some demographic variables to the equation, and we put J subscripts on there, meaning I'm going to let all the demographics and all the prices have product specific effects. So the price of tomatoes, the price effect of tomatoes could be different than, say, the price effect of ground beef, and likewise. So the effect of income on tomatoes is going to be different than the effect of income on ground beef, for example. So let me just look at a few of those chat questions that came in just to make sure I'm getting in there.
There is, I think, only the last one which we didn't pick before. So that's about power.
Yeah, so there's a question about identification of some of the main effects with the blocking. Yeah, I mean, again, I'd say this is maybe a very indirect way of saying it. Well, let me skip that question for a minute and just say that the model seems to estimate just fine. You could put in different starting values and you converge on the same effects. There does not seem to be any problem with identification of the parameters that we have here. So it is, again, the way to think about this is we have 72 different price combinations with 21 different products. You could think about the data set. One way of kind of thinking about the data set is 71 times or 72 times 21, which is quite a lot of variation. A more important point is, how much variation do you think you really have in time series data? Over any point in time, particularly the kind of stuff that gets aggregated over time. But this is going to be our base kind of model that we're going to use. So again, the thing that makes this a little different is, if we assume that error term, which I didn't show you, has the normal properties that we have in a multinomial logit model. So it's, independent IID, type 1 extreme value, you can end up with this very, familiar logit formula, this conditional logit formula. The difference here, though, is you're not choosing the probability of say, picking ground beef. You're identifying the probability of choosing a particular basket. So what's the likelihood of choosing this particular combination of items over any number combination of different items? So that's what makes this a little different. And even though, for example, you still have some of the same problems that you have with with the conditional logit model, that the IIA property, the independence of irrelevant alternatives property, this is imposing IIA across baskets, not across products. And as I'll show you in a minute, your cross price elasticities can really take on basically any magnitude that you want. It does, you don't have these problems like you have in a conditional logit where all the cross prices are the same. So that's the model, but the model has a problem. And maybe this gets back to some of the questions about dimensionality here. And here's the problem. So now let's abstract away from the fact that we have 72 different price combinations. Let's just take a single choice set at prices, whatever the prices are that are assigned to that particular choice set. Any given consumer could possibly create 2 to the 21, because we have 21 food products, different baskets. So just think about it. I can choose tomatoes and ground beef. I can choose tomatoes and lettuce. I can choose tomatoes and bananas. Or I can choose 3 sets of things. I can choose tomatoes, lettuce, and ground beef, and so forth and so on. So even at a given set of prices, then there are over 2 million, so this is a precise number, 2,087,152 possible baskets that a consumer could construct depending on how they pick their bundle of items. So in other words, the denominator over here, you're summing over 2 million possible, utilities of baskets. So I don't know, with today's supercomputers and so forth, I suppose that's, possible computationally, but it's really a challenge also then when you start talking about the fact that I've got over 1,000 participants, so 1,100 people. Each person answered did 9 baskets. So my sample size is effectively, or not sample size, but this, numerator down here, if I, aggregate over people, products, so forth, is, 2 million baskets, 1,000 people, 9 choices. You end up with like 21 million basket observations. So, the sort of dimensionality, the sample size, effective sample size is just absolutely enormous here. So how do you handle that problem? There is a literature, it's actually a somewhat older literature that deals with this in the context of just conventional choice models that have a lot of options. And a kind of a common approach, there's an author named Bhat, B-H-A-T. He has a large number of papers in the transportation literature. Even Ben Akiva, who's has a lot of papers in this literature, suggest a variety of these things. One is, well, okay, rather than putting all 21 million possible alternatives in that denominator, just randomly sample from the options that were available to people and use that approach. And that's been used in a variety of papers. You got to do some stuff to fix the standard errors and so forth. But still, I'd say this is computationally pretty darn challenging. There are some other papers that suggest limiting the number of options you think people consider by using, models like a random regret model. There's a different approach, which is this MDCEV model that Bhat introduced. And it really is trying to model, it allows for the fact that people can make multiple discrete choices. And so in a way, it sounds like this is a perfect model for what we have. But if you look at the actual model itself, it's really not. What it's trying to calculate is the fact that as you add more items to your cart, you have diminishing returns. So it's implicitly sort of assuming all the products are pretty strong demand substitutes for each other, and that your total utility is concave because of it. As I add more products to my basket, I'm kind of reaching a saturation point, sort of diminishing utility. I could actually, even under this basket-based model, I could aggregate and use the demand system. In fact, I've got a student that's sort of doing that now just to see how it compares to what we have. But what we're going to do, so despite these alternatives, is we're going to use this multivariate logistic model. So that's what I've already set up for you. The question is, how do we actually estimate it, given the challenges I mentioned before? And we're going to estimate it using something called a composite conditional likelihood function approach. And it actually turns out to make the estimation quite easy relative to how you might think. A couple other questions that came in. I'll try to answer those too. So Dan, hey Dan, good to see you in the chat here. He asks, in this approach, the items can be substitutes or complements. If so, does the model handle it? The answer is yes, it can. I've been working on trying to actually derive the conditions under which something is a substitute or complement, and I haven't been entirely successful in that regard. But I can tell you it, just to back up for a minute, it depends pretty heavily on the sign of this parameter right here, this gamma parameter. So this is sort of telling you whether something is sort of a substitute or complement in utility, whether utility is sub, additive, or super additive. But the elasticities do seem to relate directly. I wouldn't say exactly 100% one-to-one, but the sign of the elasticities also seem to correspond to these parameters as well. So just for time's sake, I'll try to get through the model here really quick. So this is that model again. This paper from the 1970s basically says, with some pretty mild assumptions, which is that the diagonals here are 0 and the cross sort of cross effects are symmetric, you can express these things in terms of conditional likelihoods. So in other words, what's the probability I place tomatoes in my basket? It's just a simple logit model. Where this, part of the logit model is, here's that alpha term we had before, is depends on whether I have other items in my basket or not. So the probability of me placing tomatoes in my basket, now this is just a dummy variable for whether I also put, say, ground beef in my basket, lettuce in my basket, or so forth. The cool thing about this paper is it shows that these parameters in these simple logits are the exact same parameters in this model here, even though these are just binary logit models. So what I end up doing here is because I have 21 products, I estimate 21 binary logit models, and these models have to have some cross equation restrictions because of this thing here. So I'm going to restrict those across equations, but otherwise I'm just estimating logit models, simple logit models. And I don't have that problem of that 2 million, observations showing up in the denominator during the estimation anyway. Now I do need that if I want elasticities. So here's how I calculate the elasticities. Once I have the estimates, I then calculate the probability of choosing all of those 2 million possible baskets. And I do it at a set of those median prices that I used in my design, and at least for now, the mean demographics. Okay, then what I can do is I can look across all 2 million of those baskets and say, for example, how many of those baskets contain tomatoes? And I just sum up the probabilities across all those, and that's sort of the probability of having tomatoes. And then I could just redo this calculation at a different set of prices, say increase the price of tomatoes by 1%, redo the calculation, see how that probability changes, and I've got an arc elasticity that I can calculate there. So that's the basic setup. So I want to show you some results. I don't want to run out of time before I get to the meat of the matter. So these are just descriptive results, no modeling here. One thing you might be curious about is, on average, how many products did people choose? So this is conditional on people that didn't choose none. So if you said, I don't want any of these, that's not in this data. If you're curious, about 10% of people said, I don't want any of these. And about 90% of people put at least one thing in their basket. So you can see the most common thing was to put about 3 to 4 items in the basket. There's a really small share of people, or these are not just people, these are both people and baskets that they evaluated. A small share of people put everything in their basket. You might ask how realistic that is, but it's a fairly small group. In a way, I think this is kind of as some sense of face validity that the method has some internal merit, that on average, people are placing more than one item in their basket. So if you give people the opportunity, they're not just going to choose chicken or steak. They might put more than one of them in their basket. If you're curious about some of the most popular items, again, this is among people that put at least something in their basket. About 41% of all the baskets contain chicken breast. So very popular item, followed by lettuce or salad, potatoes, tomatoes, bananas, so forth and so on. The least popular items were some of the canned, frozen, and dried fruits. But even these, you can see, were in roughly 6% of all the baskets that people created. You can also see the advantage of this kind of approach by seeing the pattern of choices. So see if I can pull out my pin here on this thing. So let's look. These are the people that only put one item in their basket. So look, the frozen pizza. See if I can turn on the drawer here. Yeah, so 11% of people. So among the people that only put one item in their basket, 11% put pizza and 4% put lettuce. But look over here at people, for example, that put 6 items in their basket. Now, almost, very few of them put a frozen pizza, and a lot more of them put lettuce. And this makes perfect sense to me, right? If I'm only going to buy one thing at the grocery store and I need a meal, why not go for pizza, right? But if I'm actually creating a meal for myself, it's a lot more likely I'm going to have lettuce, right? Because lettuce is going to be a complement probably to other items in my basket. I'm going to have a salad and I'm going to have something else. So you see things like, lettuce being much more popular in bigger baskets, whereas something like a frozen pizza, if I'm going to go the trouble of actually, preparing a meal, I'm not going to do the frozen pizza. I'm going to choose some raw ingredients and do it myself. So I think this sort of pattern also helps us appreciate the fact that this approach has some intuitively appealing kind of patterns of results. This is a little bit of a messy slide, but I just wanted to show it to you to see that there's a lot of really interesting results. These are just the joint, again, no model here. This is just the raw data. This is the joint probability of selection. So 18% of people who put at least something in their basket put both an apple, and number one is a banana, put both apples and bananas in their cart here. So that's the joint probability of selection. You can see, maybe one of the higher ones on here is right here. So this is tomatoes and lettuce. So it has a pretty high joint probability of selection. Makes sense, right? You might put a tomato in your salad. These others that you see there are conditional probabilities. So this is the probability of buying bananas given that you have apples in your cart. You can see it's pretty darn high. So the 68% chance of buying bananas if apples are already in your cart. And most of these you can see are pretty high, meaning that if you put at least something in your cart, likely you're going to have another thing in your cart, but it's not always symmetrical. So this is the probability of having, or given that you're buying apples, what's your probability of having bananas in your cart? It's something a little lower. So anyway, I think it's just, it's fun to just look at these numbers because there's a real rich kind of set of results here. Maybe one of the higher numbers is again here. So given that I have lettuce in my cart, there's a 72% chance I'm going to have tomatoes in my cart, in my basket as well. So just to build up to the kind of model, there's a lot of possible parameters here, but I consider different versions of the model. So first, there's a model where you just have those baseline utility effects, the alphas, with no demographics or anything else. Then I've got a model, so that just has 23 parameters because I have 21 food products plus a none option. So that's 22 plus a price effect. So that's 23 parameters. I can do that same model, but now incorporate all those cross utility effects. The ones like, if I have bananas, do I also put in, tomatoes? So that model has 233 parameters. You can see you get a pretty decent improvement in AIC and BIC as we go from here to here as these fall. The next model, I allow the prices of each item to vary. So I'll let the price effect for, say, tomatoes be different than the price effect for ground beef. AIC improves, but the BIC doesn't. So we're kind of in a conflicting situation as to whether that's a good or bad move. But this last model here, where I add demographics in, is really the best fitting model overall. If I look at the kind of model fit criteria. So the final model we have in the paper has 385 parameters. So it's a lot of parameters to try to make sense of. But I think we can do it. They make some logical appeal. So here, there's a lot on this slide. So when I advise my graduate students, I tell them to never make slides like this, but so forgive me. But I'll pick a couple of examples and just kind of talk through them. These are those alpha parameters.
Just to warn you, Jayson, I think we have about 5 minutes left.
Okay, good. Yeah, very quickly. These are the alpha parameters. So this is, take apples, for example. So this is a baseline utility of apples, how it varies with demographics, and this is the price effect for apples. So all of our price effects are negative, as we'd expect. So apples go up, in price. We're good. Baskets that have apples are going to fall in utility, and so forth and so on. Some of these, I should say, virtually all these effects, you can look in the paper. I didn't want to put the standard errors in here to make it even messier. Are statistically significant. These income variables I think are kind of interesting. So look at these are low and middle income relative to high income. So chicken nuggets, for example, much more favored by low and middle income relative to high income. Whereas, things with negatives, so take strawberries, less favored by lower and middle income than high income consumers. We got some gender effects here too, for example. These are females apparently don't like beef hot dogs as much as males. I'm not going to show you the entire matrix, so this will be a 21 by 21 matrix of all those cross price, or not prices, but the cross utility effects. But this just shows you the first subset of 7 of them, and you can see, for the most part, you can see one negative here, but for the most part they're all positive, meaning sort of in utility these are kind of complements in utility, that if I have strawberries, my utility of having strawberries goes up if I also have apples in my basket. So as a consequence, this is my matrix of elasticities that, I know it's really messy, but all the diagonals here are negative, and I think very reasonable sign. In fact, here's ground beef, minus 0.6 is very similar to other estimates we have from other approaches. But the thing that's different here, almost all of our cross price effects are negative, meaning products are complements with each other. So we have sent this paper to review, and I'd say, probably the biggest stumbling block we've had are some of the reviewers saying, I just don't believe you that all these products are complements with each other. So is that a feature of the way that we've asked our question? Is it something in our modeling approach? I don't know. At this point, I'm just telling you this is what our results are. That it does suggest most of these products are complements in the context that we've asked this question and studied them. I would say that you can certainly find papers in the literature that include at least aggregate, say, vegetables, fruits, and meat, and you can find papers that do estimate them to be complements with each other. So I don't think it's crazy. So I know I'm almost out of time, and we don't do it in the paper yet, but I'm thinking we'll probably hopefully add these. The elasticities are interesting in and of themselves, but you might wonder, so what? What can we do with these? I think one approach here, that we're working on now is, what if we wanted to implement carbon taxes? This would probably primarily affect our meat options, probably the beef options the most. But because we know what each and every product is, and we can link each and every product to a nutrition facts panel, we can determine nutritional consequences of different taxes. We could, of course, compare, say, fat and thin subsidies if we wanted to. I think this approach is really well set up and designed to look at distributional impacts of, say, food price policies. Those elasticities I showed you, those are at the average demographics, but you could do it for high income and low income, for men, women, whatever. All those things are in the alpha parameters. The other thing we could easily do with this approach is calculate welfare effects of, what's the utility, or how much would people be willing to pay for a new product, or if we banned a product, for example, we could calculate the welfare loss from doing that as well. So just to wrap up real quick, I think hopefully this is a promising approach. I guess that's up for you to decide. It's certainly the case that it allows for richer substitution patterns. We're estimating mostly the price elasticities or complements. That it doesn't have to be that way. They could definitely be substitutes. One thing we're not doing at the moment is all the preference heterogeneity that's coming in the model now is through that alpha parameter, and we're letting it vary with demographics. You could take this model and do something like a random parameter type model. The issue is we already have 300 parameters we're estimating. So, I guess you can choose, pick your battles, but it's certainly possible. It's something that's definitely doable if you wanted to do that. So I've got some other work that I'm working on now, but I'm not going to talk about that since we're almost out of time. So I'll stop there, and happy to take other questions or comments if you have them. Oh, I think you're on mute, Michelle.
Sorry, that needed to happen. Yeah, I was saying thank you very much for your presentation. I think we can take a couple of minutes for questions, given that we run a bit out of time. And the first one that I saw was from Gianluca. He was basically asking whether respondents were subject to any constraint in terms of the maximum number of items or the maximum budget that they could spend, or they were allowed to freely choose, basically.
We did not constrain that. So we allowed that, if you put all 21 items in your basket, your total is the sum of all those prices. Our concern is if you give people a budget constraint, now we're losing some of the richness that you may get from, say, high versus low income households. You might expect a higher income household to add more to their basket if you wanted to. Now, I guess one adverse consequence is now total expenditure is endogenous. We're not exogenously varying that. We're letting it endogenously vary with people's choices. But we felt like that was the right decision to make in this context.
Brilliant. I've seen Brett has a question. Do you want to go ahead, Brett?
Online. Thanks, Jayson. That was wonderful. Thank you for coming to present to us. We all enjoyed it. I'm chugging a few technical issues, which I'm sort of confused about, I guess. One was to do with, I thought you had an orthogonal design, and then my limited understanding of this would suggest to me it's very difficult to get interaction effects from an orthogonal design or get them cleanly. I wonder if you comment on that. The second was, I was a bit confused by your utility function. And particularly, it seems to me if that's an indirect utility function, you'd only expect to get one parameter of the marginal utility of income. But you seem to be estimating different parameters on each price, as if you expect that marginal utility of income to differ according to what I spend my money on. I didn't quite follow that. It might be because I'm not quite following what you're doing. But
they're actually very good questions, Brett. So let's see if I can remember. So the orthogonality has to do with only with prices. So the orthogonality means that all the prices are uncorrelated with each other. The possible cross utility coefficients, I think, mainly come about from the fact that each consumer can possibly construct that 2 million possible baskets, and we probably don't observe all 2 million baskets in our sample. Of course we don't, because we don't have that big of a sample size. But I bet we get a lot of them in there. So you get a lot of variation in those baskets that people are constructing. Actually, that's something I should probably do, is calculate how many different baskets do we actually see observed in our data set. But that's what identifies those gamma parameters. So your question about the marginal utility, yes. So what I can empirically estimate different price effects for different parameters. What I think, if I don't want to put words in your mouth, but one thing you may be saying is, even if you can do it, should you do it? Maybe you should impose an economic constraint that we're going to impose the fact that the marginal utility of income should be the same across all these parameters. I can buy that. In fact, that last bullet point I had about welfare effects of new product introductions, I've got a problem in the way I do it now, because now I don't know which marginal utility of income do I use if I do that.
Yeah. I mean, it struck me that the building that utility function from the sort of the underlying utility functions used for aids or quades or those other sorts of demand functions might be a good way to go to give you that sort of structural consistency, and also allow you to do what you said your graduate student was doing, to aggregate up to a demand system. It might be interesting.
So that aids are like Quade's model. Actually, we're doing that now. You can do it. What happens though is you got to, at the individual level, really all you observe are ones and zeros. Like, is that product in my basket or not? So it does require some aggregation. And when we aggregate, the way, what we have done is, because there are 72 unique price combinations, we just aggregate over those, for a particular price combination, how many people purchased, let's say, lettuce at that price combination, how many people purchased ground beef. So you end up essentially with 72 observations in that framework when you go that route.
Great. I've seen a couple of more questions in the chat, but I think we are running out of time. So if you agree, I mean, we can close it here, and we can save the questions like the chat, and we can send those over. Sure. I would love to stay more, but I think we already ran a bit out of time. So
yeah, you're in charge, so I'm following your lead.
All right. So I'll make sure I save if I find the button, I think there is the way to save it. Save chat, yes, perfect. And I'll send it over by email. Well, thanks very much, everyone, for attending. I think maybe the very last thing I had to share was basically that our next LEEPout seminar is on the 18th of February with Antonio Bento. And we are now putting together a new round of seminars, which will be announced soon. So if you haven't signed up to our mailing list, or either do that by emailing us or visit our website, and all the information will be there. So thank you very, very much to Jayson for his time and the wonderful presentation. It was really inspiring and thought-provoking. And thanks everyone for participating. See you hopefully next time.